Alright guys, so now we're on to tornadoes. With tornadoes, sometimes people call them twisters or cyclones. There's nothing wrong with that. They're just different names for essentially the same thing. But I mention it because sometimes people think they're all different things and get mixed up with hurricanes, typhoons, tornadoes, twisters, cyclones. We're all talking about the same thing. So hurricanes are the same thing as typhoons. Tornadoes, twisters, and cyclones are all the same thing. So let's get that out of the way. In order to get a tornado, we need to have a cumulonimbus cloud. So we're talking about those tall anvil-shaped clouds, severe weather associated with them, thunder, lightning, that type of thing. In order to get a tornado, we have to have extreme low pressure along with rotational movement. So we have to have severe low pressure along with rotation. Less than only 1% of thunderstorms produce tornadoes. However, the United States has over 90% of the recorded tornadoes for the world. So if you want to study tornadoes, there's no place better than the United States. We have over 90% of the world's tornadoes, and even though all thunderstorms, only 1% actually might produce a tornado, if you want to study tornadoes, there's no place better than America. The United States has more tornadoes than anywhere on the planet, and we'll talk about why that is in a minute. So in order to form a tornado, we have to have a flat area where there's low friction. We also have to have contrasting air masses, or essentially a strong temperature gradient. So there's a few things going on here. We have more tornadoes than anywhere else in the world. In fact, tornadoes are so commonplace that we hear about them on the news, and we usually don't think too much of it. I mean, we feel bad for the people, but you know, it's a pretty common thing. You hear about it on the news pretty often. We have Tornado Alley in the Midwest, where we have the Great Plains, and this is where it's very flat. It's great for agriculture, great for growing things like corn and soybeans, but the problem is that it's very flat, so there's very low friction. We're unlikely to get a significant tornado in the Northeast. We do have tornadoes occasionally, but they're usually pretty small. We're unlikely to get a significant tornado in the Northeast because we have a lot of hills and mountains. We have high friction. In places like Nebraska, of course Kansas, Wizard of Oz, low friction, very flat regions of the country. We also have this contrasting air mass. In the south, in the southern states, it's very hot and it's typically very humid. We have a maritime tropical air mass because those southern states are near the Gulf of Mexico. In the north, though, we have a continental polar air mass. We have states like the Dakotas and Minnesota, where it's very cold, and even air up in Canada. So we've got very warm, humid air, maritime tropical air, clashing with continental polar air, that cold, dry air out of the north. And it's a combination of those two different types of air colliding that form the severe weather and eventually might form a tornado. So we need these things to form a tornado. So we need the flat land of the Great Plains. Actually, let me go back to that for a second. So the flat land of the Great Plains, and here we can see a nice blue sky and some cumulus clouds. This is a very common sight if you ever go out there, and we can even see the shadows of the clouds on the ground. But when the conditions are right, all of these cumulus clouds start clumping together, forming cumulonimbus clouds. And if they're severe enough, we get tornadoes. This map is showing the different air masses. And here we've got our continental polar air mass. Here we have our maritime tropical air mass here. Some of you emailed me questions about this in regards to the Weather Patterns Lab. This is kind of what you're looking at. So if you were stuck on that on the lab, you might want to pull your lab book out and take a look at this map, because this map, well, I mean, I'm kind of hinting at it, but essentially it gives you the answer. Okay, so you might want to just take a look at this and your lab book. But we have the continental polar air, the maritime tropical air here. Where they meet, we're going to get precipitation, we're going to get a front. If the cold air is pushing the warm air out of the way, we have a cold front. But this is the recipe to form a severe storm, and if it's strong enough, it might be a tornado. There's a lot of people that build their living around chasing tornadoes, storm chasers, and they'll get in vans specially outfitted with Doppler radar and all kinds of instruments to try to figure out where the tornado is going to go. And this is obviously very dangerous business. A few years ago, some storm chasers were killed by a tornado that went the wrong direction on them unexpectedly. But they'll drive around seeking out tornadoes. And what they do is they photograph them, they study them, they make video of them, and they actually make their money most of the time by selling the photographs, selling the video to the news media. And that's how they fund this type of work typically. But it's very interesting, even though it's very dangerous. So if we look at the stages of a tornado, and I really don't expect you to write down everything. I know that, some of you will just sit back and watch these videos and not write anything down, as long as you get what you need to out of it. Okay. Others will write down every single word. What I'd encourage you to do is write down some of the important key ideas. I don't expect you to write down every word, but again, these concepts aren't in your class notes, and you do need to be familiar with them. Use your judgment, I guess is what I'm saying. So when a tornado starts, we start out with what's called the dust swirl stage. We're going to see a little bit of air circulating on the ground. There's going to be no funnel. You won't actually see a visible vortex. A vortex is the funnel of the tornado. You're not actually going to see anything yet, but what you might see is some dust or some light debris starting to circle around the surface. So here we've got some dirt and debris circling around on the surface. And up here we have what's called a wall cloud. This is the funnel of the tornado is beginning to drop down from the sky, but it hasn't really started yet. This is the dust swirl stage, baby tornado. And so we've got the wall cloud up here. We've got the dust swirl happening there. The tornado will form within minutes. Tornadoes are relatively short duration. Hurricanes last a long time. Tornado, maybe 20 minutes to an hour, maybe 2 hours tops, but they usually have a pretty short lifespan. And that's one of the things that makes tornadoes so destructive too, is that they are difficult to forecast. And we may have an idea that tornadoes are going to form, but pinpointing exactly where and when is very difficult, and that's why there are the storm chasers. But anyway, this is the dust swirl stage. After a dust swirl stage, the tornado starts to become more organized. We get our condensation funnel, the actual funnel that we see of the tornado. And it starts to descend towards the ground as the pressure gets lower. The tornado can dissipate at any stage. It might not ever make it past the dust whirl, or it may begin to organize and then fall apart. This is very common. But here we can see the beginning of the organizational stage. The funnel is beginning to form. And here we can see it better in this image. Okay, we're getting the formation of the funnel. Here's another one, right near a highway. Then the tornado will reach its mature stage. The vortex is at its greatest size and intensity. It often has kind of a wedge shape to it. The wall cloud dropping down from above is very organized as well. And we can visibly see the rotation. Okay, here are some photographs of tornadoes. Here are some storm chasers over there taking pictures. Sometimes we get multiple tornadoes out of one storm, multiple vortices. After we reach the mature stage, we get to the shrinking stage. The diameter begins to shrink. This is due to what's called angular momentum. And this is kind of a strange idea, but as the tornado shrinks, its wind speed increases. This is similar to figure skating, believe it or not. If you ever watch a figure skater, when they rotate, when they spin, they tuck their arms into their sides. And by just simply tucking their arms into their sides, their rate of rotation, their speed increases. And we see the same effect with tornadoes. As the funnel starts to shrink, the rotation increases in a similar way to the figure skater pulling their arms in. The vortex may begin to tilt as the base starts falling behind. The bottom of the tornado is moving slower than the top of the tornado, and it begins to tilt towards the side. We might see a shrinking or disappearance of the wall cloud. So now it's starting to shrink. And then we finally get to the decay stage. The vortex becomes stretched out into these rope-like forms, and we can see it begin to decay and break down. And notice the times. Okay, 1 minute, 1 minute 30 seconds, another minute, 1 to 2 minutes. These times are this all happens very quickly. The timing of a tornado is short but intense. Before hurricanes, we had the Saffir-Simpson scale. For a tornado, we have the Fujita scale. And actually now meteorologists are using what's called the enhanced Fujita scale, which means instead of just F0, F1, F2, F3, F4, F5, they put an E in front, EF1, EF2, EF3. It's essentially the same scale, though they've just made some modifications to it. We use the Fujita scale in a similar way as the Saffir-Simpson scale, but it's different in the way that it's used. The Saffir-Simpson scale for hurricanes is based on wind speed. Because we can't really measure the wind speeds directly in a tornado, the wind speeds are too high, we never know where and when a tornado is exactly going to occur, we can't really measure them. So what we do is we look at damage indicators in a similar way to the Mercalli scale, if you remember from earthquakes. We're looking at the damage after the tornado has occurred. So for example, in F0, very light damage, tears branches from trees, rips shallow-rooted trees from the ground, etc. And we can judge wind speed based on the damage. So the wind speed isn't measured directly, it's assessed by the damage after the fact. If we look at F5, the most destructive, incredible damage, cars become projectiles as they are hurled through the air, entire houses are completely destroyed after being ripped from the foundation and sent tumbling into the distance. Steel reinforced concrete structures can be seriously damaged. So this is the Fujita scale, 0 to 5, 5 being the strongest. There are flaws with the Fujita scale, and if you think about it, there are actually numerous flaws. Building techniques are going to be a flaw, where we have structures designed to handle severe weather. There's going to be less damage than places that are more susceptible to building damage. Also, too, since it's built on damage, or since the scale is centered around this idea of damage, what if there isn't really anything to damage? What if a tornado takes place in a farm field? Or what if a tornado takes place in the middle of a prairie where there really isn't anything to destroy? It might show up as an F0, but maybe it was really an F4 or an F5, but we just don't really have the damage to rate it. So that's one flaw. Another flaw with the Fujita scale is that it's again based on opinion. It's subjective. In order to measure or implement the Fujita scale, what actually happens is people go out on the ground after the tornado occurred and they have to rate the damage. But again, it's based on opinion, and maybe some person's new on the job and rates this a little harsher. Just like teachers grade things a little bit differently, different Fujita scale raters are going to rate the damage a little bit differently. And that's where, there's some flaws with the Fujita scale. So I'm going to divide this into two parts as well, just like the hurricanes. So I think this is a good natural cutoff point, and we'll pick up with tornadoes again in a moment.